Let's talk about multiplying rational expressions. There's some steps involved when we want to multiply. The first step is to factor the numerator and the denominator of each rational expression that you're multiplying. Number two, cancel common factors that are in the numerator and denominator. So in other words, if they are up and down from one another or if they're diagonal from each other, you could cancel them. But ones that are right next to one another, you cannot cancel. And then write the factors that are left in the numerator and the denominator. And last but not least, check to make sure that you have simplified and canceled all common factors, or you've simplified the numbers and variables that are out front as much as possible. Let's take a look at some examples of this. So in our first example, we have some monomial expressions. So we have 4x squared over 5y times 7y over 12x to the fourth. So when they're monomials, we can't do any more factoring since there's just one term. But we could cancel, like the 4 and the 12 are diagonal from each other. So 4 goes into 4 one time, so we could replace it with a 1. And 4 goes into 12 3 times, so we could replace it with a 3. And then we think about our exponent rules. We have x squared on the top here and x to the fourth on the bottom over here, or in the denominator. So x squared would cancel 2 of the ones down here, so we no longer have 4, we'd be left with 2. And then we have 7y in the numerator and 5y in the denominator. So these y's would cancel. And now it's time to bring over what we have left. So in our numerator, I've canceled everything here. I have a 1 times 7, so that would just be 7. In the denominator, I have 5 times 3, and I have x squared. So it's good to write nice and neat to keep up with the terms that you have left. And then you check and see, can I divide 7 and 15 by the same number? No. And then x squared is the only variable I have left on this one. So I'm done with that problem. Now for number 2, example 2, we have 8y minus 4 over 10y minus 5 times 5y minus 15 over 3y minus 9. So these have some binomials that we could probably take out some greatest common factors first and then simplify. Because the way they are right now, none of them are matching. So from 8y minus 4, we could take out a 4, and we would have 2y minus 1 left over. In the denominator, we could take out a 5, and we would have 2y minus 1 left over. We're still multiplying, so I bring that over. In my numerator, I have 5y minus 15, so I could factor out a 5, and I would have y minus 3 left over. And then in my denominator, I have 3y minus 9. So I could factor out a 3, and I would have y minus 3 left over. So now I have everything factored, all numerators and all denominators, and I can cancel out the factors that are matching, or the ones they have in common, as we say. So 2y minus 1 cancels out, y minus 3 cancels out, and then I have 4 times 5, which is 20, over 5 times 3, which is 15. And that would reduce to give me 4 over 3. But notice over here, if I had gone ahead and canceled those 5s, I could have just brought over 4 over 3. But if you forget, you just need to check at the end and make sure you've simplified as much as possible before you're finished. So let's look at example 3. We have x squared minus 4 over x squared minus 1 times x plus 1 over x squared plus 2x. So in my first rational expression, I have some differences of squares over here. So I need to factor x squared minus 4 into x plus 2, x minus 2. And in the denominator, x squared minus 1 is also a difference of squares. So that would become x plus 1, x minus 1, multiplying, so I bring my sign over. Now in my numerator, I have x plus 1. Now that one does not have anything we could take out, and it's not a difference of squares, and it's not a trinomial, so it's not factorable. We just bring it over. And then x squared plus 2x, we could take out a greatest common factor of x and we would have x plus 2 left over. So once you get everything factored out, you can start canceling. That's the fun part. So x plus 2 and x plus 2 are diagonal from each other. And x plus 1 and x plus 1 are also diagonal, so that's okay. They can cancel out. As long as one is in the top and one is in the bottom, they can cancel. And then we have left x minus 2 in the numerator. And in the denominator, we have an x and an x minus 1. And you'll usually see these kept in factored form, they call it. But if you did distribute, it's not incorrect. They just normally you would just leave it like that. Now let's look at one more. This one has a lot of factoring to do, it looks like. We have x squared minus 5x plus 6. We're going to need to factor the trinomial. Over x squared minus 4. So that's a difference of squares. We have x squared plus 3x plus 2, another trinomial, and x squared minus 2x minus 3, another trinomial. Those are two types of factoring we see a lot with rational expressions. So we want to factor x squared minus 5x plus 6. So I'm going to bring it over here. Numbers that would multiply to give me 6 and add up to negative 5 would be negative 3 and negative 2. In my denominator, like I already mentioned, we have a difference of squares. So I have x minus 2 and x plus 2 would come from x squared minus 4. Multiplying in my numerator, I need numbers that will multiply to give me 2 and add to give me 3. So that would be x plus 1 and x plus 2. And in the denominator, another trinomial. So I need numbers that are going to multiply to be negative 3 and add up to be negative 2. So that would be x plus 1 and x minus 3. So once you get it all factored out, like I say, this is the more fun part. You get to make your answer much, much smaller by canceling x minus 3 and x minus 3 would go away. X minus 2 and x minus 2 would go away. X plus 2 and x plus 2 would go away. So almost all of my factors cancel. But I am left with x plus, oh, wait a minute, nope. X plus 1 does cancel out. So actually, my final answer for this entire multiplication problem will just be 1. So it's not 0, because notice when everything divides out in math, that equals 1 over 1, which we can just write as 1.